Hello, my name is Jen Schechter, and I am the Eclipse Coordinator for the Buffalo Museum of Science. And I am here today to talk to you about solar eclipse safety. So the presentation today, gotta get on it. Presentation today looks like this. First, we're going to talk about the science of solar eclipses. We're going to talk about what to expect during the entire event. We'll talk about some special things having to do with Western New York and the 2024 eclipse. I will tell you safe ways to have an enjoyable experience and provide some additional resources, and then we'll end with an open question and answer time. So to start off today, we're going to talk about the science of solar eclipses. And an eclipse occurs when one celestial body is totally or partially obscured or blocked by another. And today, while eclipses can happen on Jupiter or somewhere else, we don't really care about those places. We're going to talk about the three main ones here on my slide. So we have the sun, the earth, and the moon. And if they line up in this order, we can get a lunar eclipse. If they line up in this order, however, we can get a solar eclipse. A lunar eclipse is when the Earth's shadow falls upon the moon and it dims the surface, except it doesn't turn black or go gray, it turns red. And that's because the sunlight is going through the Earth's atmosphere. The more stuff that's in the atmosphere, the redder the surface of the moon will be. Before we talk about solar eclipses, there are two important moon facts to know. The first is that the moon's orbit is not perfectly spherical. It's not a perfect circle. It's more oval or elliptical like this. That's important because sometimes the moon is closer to Earth and sometimes it's further away, and that impacts the type of solar eclipse you might see. Second, the moon's orbit is not perfectly lined up with the Earth's. It's skewed about 5 degrees. And that means while the moon might come in between the Earth and the sun, if it's not lined up, if it is above the Earth, if it's below the Earth, you won't get a total solar eclipse or an annular eclipse for that matter. So in regards to that elliptical orbit, to the moon being further away or closer away, has to do with the type of solar eclipse you will get. An annular solar eclipse occurs when the moon is further away in its orbit and there's still sunlight streaming around the edge of the moon. The moon doesn't fully block the surface of the sun. A total solar eclipse, though, happens when the moon does fully block the surface of the sun and it makes the sun's outer atmosphere, called the corona, visible. Normally, we can't see the corona because the surface of the sun is so bright. And lastly, a partial solar eclipse is when the moon only covers a part of the sun and creates a crescent shape. Before and after totality during a total solar eclipse, you also get a partial eclipse, the same with an annular eclipse. So again, a total solar eclipse happens when the moon comes between the sun and the Earth. It's close enough in its orbit, it's at the right angle, and it can block the entire surface of the sun. And those within the roughly 100-mile shadow, where all the light from the sun is blocked, they're in the umbra, the darker part of the moon's shadow, are in the path of totality. Those outside of it, but within a certain distance, within the penumbra, the lighter part of the moon's shadow, will see a partial eclipse. So everyone in the contiguous United States on April 8th will see at least a partial eclipse. The path on April 8th, 2024 will range between 108 and 122 miles, but so the umbra is about that wide, but the penumbra is much larger. So it encompasses more of the United States. So this next part is a video that NASA created. It's a simulation of the moon shadow moving over the Earth. The green lines there are the outside of the path, so people outside of that would just see a partial. But the red line there is the center line, and you'll notice that's the largest part of the circle, so people on the center line have the longest totality. This also shows just kind of how fast the moon's shadow is moving. When it makes landfall in Mexico, the shadow will be moving more than 1,500 miles per hour. That's almost twice the speed of sound. When it reaches Western New York, the shadow will be moving about 2,300 miles per hour. The last important fact to know is in regards to size. So we know that the sun is very big, And actually, if you drew a radius, so if you took a point right in the center of the circle of the sun and drew a line to the outside, it would be about 435,000 miles. And if you did the same thing on the moon, it would be just over 1,000 miles. So the sun is 400 times larger than the moon. And if that's the case, how can the moon cover the surface of the sun? Well, the sun, while 400 times larger than the moon, also happens to be 400 times further away. So the sun is about 93 million miles away, while the moon averages about 238,000 miles away from us. And so because the moon is closer, it makes them both the same size in our sky. So it is able to cover the sun and create a total solar eclipse. So the next thing I want to talk to you about is what happens during a total solar eclipse. So now that you have the general science down, I want to go over the phases during a total solar eclipse. And it starts off, these times are specific to Buffalo. So the further you get out, the times might be different, but these are for the Buffalo Museum of Science. And it starts with first contact. So the moment the edge of the moon touches the edge of the sun, the event begins. You can start to watch as it kind of takes over more and more of the moon. And that'll happen between 2:05 and 3:18. The moon will gradually cover more and more of the sun, and it'll create this really cool crescent shape. And then at about 3:18 and 10 seconds, you'll get the diamond ring effect. So it's the last bits of sunlight that pass through the valleys on the moon's limb or the edge of the moon. And the faint corona around the sun is just becoming visible, and it looks like a diamond ring. Just after the diamond ring, seconds after, you will see what's called Bailey's beads. So it's beads of sunlight streaming through those valleys along the edge of the moon. Because the surface of the moon is not smooth, you get these tiny little beads created of sunlight through those valleys. Just after Bailey's beads is when we have second contact. So totality begins. Here in Buffalo, it'll be at 3:18 and 20 seconds. And it's the moment the moon fully covers the surface of the sun. This is the only time during a total solar eclipse that you can remove any solar filters. And we'll talk about this again later on in the presentation, but this is the only time during a total solar eclipse that you can remove solar filters and safely view what is happening in the sky. So again, that corona becomes visible. That corona will be about as bright as a full moon with clear skies, which we are all going to manifest that good weather. So then totality is going to last about 3 minutes and 45 seconds. Again, the further you are away from that center line, the shorter totality will be. So you'll want to make sure to check that. Timeanddate.com has excellent listings of all of the totalities. So if we have anyone watching that's in like really far south, Erie County, like in Collins or Jamestown, your totality will be shorter. Here in Buffalo, it'll be about 3 minutes and 45 seconds. And that's what we call third contact, when the moment the moon starts to move enough away from the sun that those bits of sunlight start streaming back through. Any amount of sunlight is dangerous to your eyes, so we recommend setting a timer, just several seconds, maybe 10 or 15 seconds shorter than what totality will be, to make sure you get all of those filters back on your eyes, back on any instruments, and to help any young kids put their solar eclipse glasses back on as well. So then following totality, you can watch everything in reverse. So there will be a new set of Bailey's beads that will appear. They'll come together to form another diamond ring. And then again, you'll see that crescent moon or crescent sun shape in reverse as the moon moves away from the sun. And then at about 4:32, we will have fourth contact. And that's the moment the edge of the moon leaves the edge of the sun and the entire event has ended. So that is about 2 hours and 28 minutes. And as long as you are wearing your eclipse glasses, you can watch the entire event occur. But wait, there's more. So if that's not exciting enough, there are other sensory experiences that you might have in regards to things that you might see, things you might hear, things you might feel. Taste and smell are up to you. Unfortunately, there is nothing to taste or smell when it comes to the eclipse. So the first part is sight. So while we will see the corona appear, we'll see that totality, it's very cool. There are also some things that happen with light. So this is a video that was taken in Casper, Wyoming in the 2017 total eclipse. You can see it was daylight, but now as it gets darker, colors get grayer, streetlights come on. But if you look at the very top of the video, you'll see sunset light, sunset colors. During totality, the horizon becomes a 360-degree sunset. You can see the light on the outside of the shadow. And it'll only get about as dark as twilight. So it won't get pitch black just like night, but because it'll get dark, if you look right where the position of the sun and moon are, you might be able to see bright stars and planets. So now you can see as the moon moves away, we come back to daytime and totality has ended. So again, during totality, looking up at the position of the moon and sun, you might be able to see bright stars and planets. And the two planets you are most likely to see are Jupiter and Venus. They will be closest to the position of the sun on April 8th. Something else this image shows you is where the sun will be in the sky. So you don't have to be anywhere special to view the eclipse. You just have to have a clear view of the southwestern sky. The sun is going to be at about a 45-degree angle. That's about halfway between its maximum and the horizon. So it'll also be high enough that most people won't have anything in their way unless you live next to like the Seneca 1 tower. And I don't recommend standing next to a tree. I do recommend going out the day before, seeing where the sun is around 3:15, so you have a good idea of where you should be standing or sitting to view the event on April 8th. The next thing are things you might hear. So we perceive the light change, but so do living things. So you might hear crickets chirping, you might hear frogs croaking right up to totality because they believe that night is falling, and they'll get really loud. And then during totality, they'll go quiet. And then following totality, birds might start to sing their dawn chorus. And then the last animal I have here is humans, because humans like to clap and say ooh and ah to things that are exciting. And so if you are in a place where there will be a lot of people, you could experience a lot of applause or people making noise. And so if you have a pet who is sensitive to sounds, or if you will be experiencing the eclipse with someone who is sensitive to sounds, just be aware that if you are around a lot of people, there could be a lot of noise coming from them. The last thing is you'll feel a noticeable temperature drop, anywhere between 10 and 20 degrees. This data was taken from Zambia from the June 2001 total solar eclipse, and it's just over a 10 degrees difference between before the eclipse started and the height of totality. So you'll feel a noticeable temperature drop. It'll get colder. And with that, you could also feel a change in wind direction. So to recap the sort of sensory experience, you might see automated street or porch lamps come on. You'll see dust level darkness, sunset colors on the horizon, and bright stars and planets may appear in addition to watching totality. Outdoor insects and animals will behave differently. Humans around you may clap. And then lastly, you'll feel a drop in temperature and a possible change in wind direction and or speed. So this next part deals specifically with Western New York and the 2024 eclipse. It has to do with looking at previous eclipses and what we have come to know may happen. So this is just to help you prepare for what may happen on the day. This is what the path looks like. So again, the eclipse makes landfall just over Mexico there. At the bottom, it moves up Mexico through the United States, and it ends over the Atlantic after going across some parts of Canada. The cool thing about this is that the shadow is moving slower over Mexico, so their totality is longer than ours, but our totality is longer than like New Brunswick's. Here's what it looks like specifically in Western New York. So as you can see, the center line goes right through Buffalo. So again, Buffalo will have the longest totality in the area. When you get down to places like Salamanca, Jamestown, their totality is about a minute shorter. Cohocton, though, is right on the edge, and the totality there will be about 58 seconds. The reason I show this map is I have a couple of reasons for showing this map. The first is that there are some fairly large cities that are right outside of the path of totality, pretty close to us, like Toronto or even London. And then there are a lot of people who are also not close to the center line. And this just means that all of those people could potentially come into the path and could potentially get as close to the center line as possible. Here's some data for you. Erie County is preparing for upwards of 1 million tourists to move through the county. Erie County already has 900,000 residents. We could potentially double the number of people in our county on April 8th. The Buffalo mainline plazas are already some of the busiest. There's between 9 and 10 million drivers each year. And lastly, a lot of school districts in Erie County have already opted to cancel school on April 8th. So fortunately, there won't be any buses on the road at the time. But all of those people who are coming through the county could mean issues like traffic or potential road closures. In 2017, Buffalo had a partial solar eclipse while there was a total eclipse going on elsewhere in the country. And we saw our exit on the 33 close because so many people were trying to come to the museum, and that was just for a partial. So we're anticipating that to a greater extent for the total solar eclipse in Buffalo. You might also see crowding at parks and open spaces and increased usage of things like increased usages of businesses like restaurants, grocery stores, etc. So what does this mean? Well, it means we just want you to plan ahead. So do all of your errands ahead of time, especially buying groceries or making sure you have enough medication and supplies on hand. We do recommend that you stay at or close to home for the duration of the event and several hours following. Again, you don't have to be anywhere special to view it. You just have to go outside and have a clear view of the southwestern sky. However, if you are planning on attending an event, especially if you're planning on attending a very large event like at Niagara Falls, plan on being there for several hours or plan on being stuck in traffic, having potential traffic issues when you leave. Again, it's just to be prepared for additional people. And this is especially true if you live very close to a large open public green space. I hate saying this part because I feel like every time I say it's cloudy, I'm just going to jinx us, but we're going to manifest that good weather. We're going to be very positive about it, but you might want to know what happens if it's cloudy. Well, if it's very cloudy, if it's overcast, if it's raining, we won't be able to see anything except it'll still get dark. And it'll get dark for the amount of totality in your area. And animals may still react to that light differentiation. So you may still hear some crickets or frogs. And all the people will still be here. We'll just all be disappointed together. But if the clouds are not completely dense, and if you can see any amount of sunlight through them, you still may be able to see a lot of the event. And it's still important to wear your eclipse glasses or use filters because clouds are not a sufficient filter for sunlight. So if you can see any amount of sunlight through, you still could see a lot of the event, the partial phases and totality, even through some clouds. But my last recommendation is that if it is completely overcast, if it's raining, NASA will have a live stream of totality in multiple locations that we'll all be able to watch. So having a safe and enjoyable experience, because it is all fun and games until you go blind. So we don't want that to happen. And the first rule of Fight Club might be not to talk about Fight Club, but the first rule of having a safe and enjoyable eclipse experience is telling everyone not to look at the sun. Why? Because it could lead to something called solar retinopathy. Solar retinopathy is a chemical injury to your retina that impacts your central vision. So the best way to avoid that is to not have it. It is irreversible. It cannot be fixed. And so we would like to avoid that. So don't look at the sun. Any amount of sunlight can do this damage to your eyes. So now taking this, I have a little quiz of which of these items can you use to look at the sun? And the answer is none of them, because none of them are properly filtered. So sunglasses are not dark enough. We already know that our eyes have no filters. Clouds are not a sufficient filter. And then instruments without filters can actually be more dangerous. So my friend here, while he might have a great idea to put on those eclipse glasses, you should never put on eclipse glasses and then look through an unfiltered telescope. It's the equivalent of using a magnifying glass to kill ants with the sun. You can do immediately and again irreversible damage to your eyes. Again, sunglasses are not dark enough and clouds are not a sufficient solar filter. So you may be asking, what are some ways to safely view a solar eclipse? Well, you can do so directly. So if you want to actually look at the event happening, you can do so directly using a filter, or you can use some indirect methods that we will talk about in a minute. So the first one is using solar filters. So this includes eclipse glasses, which I always have with me, or eclipse viewers, which has the same material just in a card. And you also need filters for your instruments. So if you have a camera, including your phone, or binoculars or a telescope, and they make the same type of filters as these glasses for those types of instruments, as you can see in the picture here. Why eclipse glasses? Well, they're the cheapest and easiest method of observing the sun. There's no magnification and they're safe to use over glasses. So your eclipse glasses either go right like this over your eyes, or they go over corrective lenses. So if you wear glasses with corrective lenses, they go over your glasses. The lenses of eclipse glasses block out 99.99999% of light. Sounds like a made up number, but it's not. And they really are best and easiest for safe solar viewing. An alternative is to use shade 14 welder's goggles. If you're not sure though of your welder's goggles rating, don't use them at all. You can still do eye damage even if they're rated, 12 or 13. An important note, if you do decide to purchase any solar filters, is to make sure that you're getting them from a reputable source. I always check the American Astronomical Society's website. It's aas.org. They have a list under their Eclipse site page. They have a list of reputable vendors and manufacturers for solar filters. And you want to make sure that you're getting the ones that are safe for direct solar viewing and that meet the requirements of the ISO certification 12312-2, which the glasses that we are providing through the museum and the libraries do. But if you're purchasing some of those filters for your instruments, you want to make sure that it meets the same requirement. If you get a filter and you take it home and you look up at your kitchen lights and you can see through it, it's not a sufficient solar filter. So you want to make sure that you're getting it from a reputable vendor, that it meets those requirements. Here are some other examples of things, again, that need filters. If you want to look through binoculars, that's great. You need to make sure that both of those lenses are covered in a filter, or if you have a telescope, making sure that you have a sufficient solar filter. If you are interested in purchasing filters for instruments, you have to be careful and make sure that they are solar filters and not just UV filters. They should be very dark, almost, they should be reflective. So these, if you look into them, they are so dark, they are reflective. And that's what you can see here with this telescope filter. The second way to safely view is through indirect methods. So the one on the left here is a pinhole viewer. It's where you put a small hole so this one is a box method. You put a small hole in a box that projects the sunlight onto a white piece of paper on the inside. And there are a lot of websites that will teach you how to make a pinhole viewer using anything from a cereal box to other cardboard. You can also use anything that has a small hole in it, and I will get to that in a minute. The one on the right is called a sun spotter. It uses a series of mirrors to project the sun on a piece of paper there on the bottom platform. And what it does is the sunlight comes into that little, there's a little window right here. The sunlight comes into it, bounces off those mirrors. And then it shows you anything that happens between you and the sun. So these two types of indirect viewing are best for the partial phases of the eclipse, and they're especially great for younger kids who have a hard time wearing glasses. So just like the pinhole viewer, the picture in the upper left-hand corner here is a colander. So anything with small holes in it, if you take it outside during the partial eclipse phases, you just hold it out in front of you and it will project what is happening to the sun onto the ground. So you'll see those little crescent suns. And I challenge every kid to find things with small holes in their homes and see if they work. Everything from a colander to a Ritz cracker. Or you can, as this other image shows, you can poke holes in cardboard. You can make an elaborate design and hold it out and see your design in crescent suns. The last image on this page are crescent suns through leaves, which I don't believe we will have by April 8th. But if you happen to be somewhere warmer, you might see the crescent suns projected through leaves. This is just a recap of when you have to have your filters on. So any part of those partial eclipse phases, you have to wear filters in order to directly view the eclipse. It is only during totality that you can remove all of the filters and look with the naked eye. And lastly, you might be standing in direct sunlight for 2.5 hours. So just a reminder to please wear sunscreen or protective clothing or hats. Though I am very entertained knowing that some of us are going to go to work on Tuesday, and one of our coworkers is going to have a sunburn with our eclipse glasses, tan lines. But we don't want that to happen. So please remember to wear sunscreen, protective clothing, or hats. So to recap this entire presentation, plan ahead for the day of, protect your eyes, protect your skin, but most importantly, have a good time. This is a once-in-a-lifetime opportunity for a lot of us, and we should really enjoy it. I do have some additional resources in case you're interested. The first is the Buffalo and Erie County Public Library has put together a information guide about the solar eclipse. It includes things like databases for students if they're interested in learning more or researching it, links out to sites like NASA, as well as a book list of books about space and the solar eclipse. I have linked out NASA's page on the eclipse coming up in April, and a shameless plug for the Museum of Science. We are doing a week's worth of eclipse-themed activities here called Eclipsapalooza. Please visit our website to learn more about the activities that we are doing. And we're also doing more of these trainings throughout the community coming up. I also have some specialized resources. So the WBFO wrote an article about having an accessible experience. NASA's Neurodiversity Network has created a flyer about experiencing the eclipse with someone who is neurodivergent, especially those who might have some sound sensitivities. And then lastly, a resource for blind or low vision people. Eclipse Soundscapes is a NASA partner that has a verbal description of an eclipse as it's occurring. Thank you. But also shout out to our sponsors for providing funding for all of our Eclipse programming and for the safety training. And I would like to now open it up for question and answer time. So the first question we have is, will the museum be open on April 8th? It will not. I forgot to say this in my presentation. I apologize. The museum and TIFT are both closed on April 8th to allow our staff to experience this awesome phenomenon with their family and friends. But beginning April 1st, we will have 7 days of eclipse-themed activities to help teach you about the eclipse and get you ready.